Okay, continuing on, we've been talking about ladder logic. Uh, the left ladder rail is 24 volts, and the right ladder rail is classified as neutral because we've grounded it. Now I have a slightly different circuit. We have the motor contactor or motor relay coil right here. But this time we have a single push button as before, but it is a normally closed push button. So if I look at that and I interpret the operation, I say that my MOT coil is actuated if my push button is not actuated. So let's give this push button a name, all right? Let's talk about its operation real quick, okay? First of all, if I turn my power on and I've got 24 volts applied to my circuit and the circuit is untouched, the motor relay or the motor contactor coil will actuate immediately because I have voltage applied through a closed switch. Current flows through the motor contactor coil. We close the contactor switches, and the motor begins to turn. If I push this button, I no longer have voltage applied to my contactor coil or relay coil, and the motor stops turning. So let's give this push button a name called stop. And if I want to, well, before I go any further, let's talk about the Boolean state classification. So if something is not actuated, it is in a state of 0. If the device, whatever we're talking about, is actuated, it's in a state of 1. In our previous circuit, we had a Boolean statement of MOT was equal to start, and the left side of the truth table was identical to the right side of the truth table. So for this one, MOT will be equal to the stop button with a bar over it, meaning that the MOT coil is equal to stop not. Or another way of saying it is that the MOT coil is equal to the stop button not actuated. The bar over the top of the variable means that the action required for operation is negated. Okay, we say negated, or we say it is inverted, or we say it is opposite what it would be with a normally open push button. So here's our Boolean statement as such. And let's take a look at the truth table. So, the stop button, not actuated, actuated, and the MOT coil will be the inverted column of stop, which says that I've got a 1 and a 0. So if the stop button has not been actuated, 0, then the MOT coil will be turned on. If the stop button has been actuated, it's equal to a 1, the MOT coil will be turned off. So for this circuit, if I don't touch the stop button, I apply 24 volts to the MOT coil, and it is actually turned on, and it's a 1, which means it's actuated. If the stop button has been pressed, MOT is equal to 0, which means it is not actuated. So, in summary, if I don't actuate the stop button, my motor coil is on. If I actuate the stop button, my motor coil is turned off. Now then, you should be able to rationalize this simply by looking at this very simple circuit and coming up with a truth table for yourself.